let's invite the Vice President of Networking Product Department of H3C with her keynote speech, SNA-Based, Self-Diagnosing, and Self-Isolating Networks. Now let's give him a warm applause.
So dear guests and our friends online, so today I'd like to share with you to navigate the new era of the intelligent network, the self-diagnostic and self-isolated network plan based on SNA. The digital transformation of the enterprise has posed a new challenge for the network. First of all, the network has carried more and more important business, from the initial web page scanning, email, to current online office, the mobile payment. So the online business has become more and more important, and we have lower tolerance towards the network fault. Second, the network has become more and more broad in terms of the connecting range, and the numbers increasing, the connection among the human beings, the connection among the human beings and the things, the 5G, IoT, etc. So the network has become more and more complicated. The more and more important business with the lower tolerance and with the more and more frequent business change, which will ultimately result to the higher O&M cost. And currently, our experts cannot even conquer these kind of problems. So how can we cope with this challenge? And our business area has achieved the consensus that is we need to rely on the machine intelligence and the AI to solve this problem. So today I would like to share with you the concept and practice of H3C of our intelligent network solution based on AI. That is what we are going to talk about, the self-diagnostic and self-isolated network. First of all, let's review about 2019. In the spring of 2019, the H3C has officially launched the ADNet 5.0 for the AI network solution. It has three big features: the one core structure, the two integrations, and three AI, the one core network of internet. That is what we know of the SNA. This structure has achieved the whole process from the design of the network to the simulation to the deployment to the AI guarantee, this whole life cycle network management capability, and has constructed the cornerstone of the intelligent network. On the other side, it has basically achieved an internet interface based on the intent, so that the internet is more easily to be understood and to translate the business intent of the users, so that the O&M of the network has become much easier. And the two integrations means that in the plan we have achieved the scenario integration of data center, the WAN, and the campus network. And we have basically achieved the management control analysis of the structure and has improved the O&M experience. The 3 AI, which means that we have achieved 3 AI model in this ADNet 5.0, and we have achieved many of the features, including local AI, the equipment AI, the cloud AI, and we have promoted the CR service center so that the AI has integrated into the every aspects of our plan and to provide them more intelligent service for our client. And looking towards the 2020, and H3C will launch the self-diagnostic and self-isolated network based on SNA and continue to forge ahead on the road of the intelligent network. With the introduction of the SDN and with the AI introduction, we can achieve the fully autonomization of the network and to fully achieve its value. So actually the autonomization is that the network can make the decisions by itself without any artificial interference, so that autonomization of the network will ultimately achieve the result that it can self-understanding the business demand and to autonomously discover the network defaults and autonomously debug the network defaults. But still, we think that we still have a long way to go to fully achieve the autonomization of the network and to without any artificial interference. So we need to achieve that goal with several steps. And today we are going to share with you the self-diagnostic and self-isolated network is actually the practice from H3C in this road. So first of all, I'd like to share with you a story about Bian Que, the physician. We know that Bian Que is a very famous physician in the spring and autumn and warring states in China's ancient times. Actually, Bian Que is not the most expert. Actually, his eldest brother and the elder brother all has better medical skills than him. Actually, his eldest brother can just find the disease before it actually happened, and his elder brother can actually find the disease when the patient has symptoms. But for Bian Qu, actually, usually those kind of patients are already quite severe in their disease, so Bian Qu will just use the kind of measures to solve the most severe disease. And that is why Bian Qu has become so famous. So from this story, we know that the skill to diagnostic is very important. So actually, we need to find the problems in the initial period. Second, as the medicine to effect, the symptoms lessened is very important. But more importantly, we need to take preventive measures. And similarly, the kind of self-diagnostic network based on SNA is also divided into two dimensions. First would be the predictive diagnosis. So through the kind of analysis of the equipment, the network, and the user's data, to achieve this kind of a predictive anticipation of the operation quality and the network default. And second is a kind of fault diagnosis. So we can just do the kind of a diagnosis targeting the kind of problems already existing and to utilize the history as well as the real-time collected data of the network to do the correlation analysis to achieve the positioning of the defaults within seconds. So actually, the network diagnosis is to have a kind of diagnosis of the health status of the internet itself. For example, like the CPU, the temperature, the internal storage, the interface card, optimal module. And the user diagnosis is to do the diagnosis from the user's dimension, from the AAA authentication, the DHCP, and the DNS. And application diagnosis is to have the kind of end-to-end SRA and business usability diagnosis. For example, like the video and audio business, the remote teaching business, and also to have a kind of a diagnosis from the application dimension. And the core technology of the self-diagnosis network first would be the AI probe, and the second would be the AI diagnosis. Because the measure of this diagnosis is our AI, and the AI depends from the data. The data is not come out of thin air. Actually, the source of data is the probe. So the most important capabilities in this would be the AI probe and the AI diagnostic capabilities. AI probe is like the kind of X-ray, the CT, the MRI in our hospitals. So these are the basis for us to make the correct diagnosis. And the AI diagnosis is like the physician or the doctor in the hospital. So why we all like to go to the expert clinic is because that those kind of experts, they are quite experienced. And the kind of a self-diagnostic network from H3C, we have the data collection capability with the 6 AI probe, the 3 network elements probe, and the 3 network probe to probe from the perspective of the whole network. So these 6 categories of a probe can have a whole scenario scanning and can provide us with a powerful data collection capability. And all of this data will be delivered to the AI diagnostic module and to be diagnosed through 2 measures. First would be the diagnosis based on the historical data and machine learning. And second would be the kind of diagnosis based on our over 20 years of network O&M experience and to do the kind of quick positioning and the solutions to the network default. And for H3C, we have already done multi-dimensional exploration practice in the self-diagnostic network. So let's have a look about this case. We have provided a kind of service for a very big insurance groups in China. So we have what kind of value we can provide them to help our clients to reduce the kind of online problems diagnosis from hours to seconds. And now let's have a look about the user diagnosis. So, for example, in a university in China, over tens of thousands of students, they need to be connected within the campus network through mobile phones. But usually the students cannot have a very good experience in this. So based on our self-diagnostic network of H3C, we have the kind of a self-diagnostic capability. For example, like the problem of the access acquisition, the address acquisition, the access authentication, and the wireless roaming. So through this kind of analysis, through these 8 dimensions, we can have a very accurate positioning of this. And so this kind of default reasons can be delivered to the end users directly through the app and can reduce over 80% of the workload of the O&M center of the internet. And lastly, let's have a look about application diagnosis. For example, for a big internet company, their headache problem is that they would lose data in the app-level application. We know that after the overlay of the network, for this kind of enterprise, they might face the problem that is quite time-consuming to find which equipment has lost data. So our self-diagnostic network has provided this kind of end-to-end network or root default diagnostic capability. And so within 1 minute, we can locate to the specific default equipment and greatly save the time for the artificial positioning and to improve the satisfaction of the business sector. So next, we would like to share with you the self-isolated network of H3C. And with the business carried by the network becoming more and more important, so we have high requirement towards the usability of the network. The user always require that our business cannot be interrupted, but the hardware will always broke and there will be bug in the software. So this we have a contradiction of the kind of so how to solve this? The traditional plan is that we will just achieve the high quality and high reliability of these internet equipment. But we found that to solely rely on the internet element is not good enough. So, for example, the kind of internet element composed of 5 9, and actually our network has the same logic to achieve the high reliability of network through the high reliability of internet element has higher cost. So we have come to a bottleneck. We need to make innovation and breakthroughs. And for our self-isolated network, the thought is that based on the unreliability of the internet element to construct a high usability network, because the individual equipments will broke inevitably. This is the prerequisites. We need to think about what we need to do to guarantee the sustainability of the business. So like this pyramid graph is the distributing graph of our network defaults. For example, like the different kind of problems listed here. And it accounts for 50% of the network defaults. And this kind of whole machine defaults account for about 40%. And as for the main components, total loss efficiency account for 10%. So actually, over 90% of the network default is because it's not good to use, and these are the problems that we need to solve. So we always hear the complaints from the users. Actually, they say that we are not fear of the equipment is totally broke because we have many other network protocol to guarantee the operation. What they really fear is to lose the data silently. That is to work just like work with illness. So another situation is that this kind of a redundant network, maybe a part of the functions of the main machine has default, and as is not working, but the backup machine is still working. So our self-isolated network can identify this kind of subhouse status to find the subhouse, to isolating the default individual, to control the range of the defaults so as to guarantee the high usability of the total network. And next, let's have a look about how to achieve it. It will be mainly divided into 4 parts. First would be the network plan design of the self-isolated network. So we need to do it from the plan design. It doesn't mean that our client needs to increase more of the redundancy and cost, because actually most of the networks now, they have the condition currently. Second is that we should have the real-time AI default diagnosis capability. That is to say, we need to use the network element probe to have the kind of historical and real-time data, and to make the quick positioning of the faults and the kind of pitfalls of the network. The third would be the network isolation and simulation based on AI. So to simulate whether the network has the conditions to isolate, and to simulate the minimum range of this isolation, as well as their influence of the business after the isolation. And the fourth step would be the kind of implementation and optimization of the network isolation. So based on the result of the AI simulation, to dispatch the isolation order and to have the isolation of the default source. For example, to shut down the terminal, or to have a kind of heat switch of the network control agreement. And also, we can have optimized configuration of the parameter of the equipment. So from this isolated design to the real-time AI probe, to diagnosis, to the simulation, to the final implementation of the isolation, you can see this is a complete closed loop process. And now we can have a look about 2 commonly seen cases. First of all, we can have a look about this self-isolated network in the campus network. For example, for a terminal, its loop default might expand to the whole network. So once this problem happened, this kind of network loop has the storm, it will just influence the whole network. And currently we have the measures, for example, like the spanning tree protocol, the MSTP, and the loopback detection. But actually, even though we have this kind of measures, due to the configuration error and the software bug, as well as the network loop will still happen. So how to identify the loop and to achieve the fast isolation from our self-diagnostic network. First, AI probe will have a real-time analysis of the live stream model of the terminal. So when they are detecting that actually the speed of the terminal is reaching its up limit, and they will just report the information of default, and the AI diagnostic module combined with the topology, the terminal, the user login, and the broadcasting data to have a analysis, a correlation analysis based on AI, and to target it into the specific terminal. And the next, combined with the topology, to do the simulation and isolation to select the most reasonable terminal to do the isolation, and finally to do the implementation to cut down the loop and to guarantee the usability of the whole network. So you can see all of this process is done through the autonomous analysis and decision making of AI. So actually the processing speed of the self-isolated network is quite fast. And we can do the second identification and the second level position and the second level isolation. And next, we can have a look about the data center fabric fault self-isolation. So this is a very typical data center spy equipment self-isolation. And the leaf, we have many of the uplink backup. So actually in this network, it has the isolated condition, but actually when one of the spy equipment has the subhouse status, maybe the ECMP will not have any reaction. For example, like the cache loss of the data, the congestion, but this equipment will continue to work and to influence the business. The traditional positioning measure is that after seeing the problem, we need to find the equipment artificially, one by one. And it lacks this kind of whole scenario perspective. But our self-isolated network, our self-isolated solution through the TCP protocol to have a real-time collection of the whole network and to have the sequential dynamic baseline to locate the exact point of the default and maybe to adopt some of the measures like to change the heat isolation and the redundant network can guarantee the high usability of the whole network. So actually the core of the self-isolation network is to isolating the subhouse internet element to control the default influence range to guarantee the high usability of the large-scale data center business. And lastly, I'd like to do a kind of summary of my topic. The H3C self-diagnostic network can empower clients to achieve the accurate prediction of the network risk and to have a quick location of the network defaults of H3C isolated network can empower clients to achieve the individual autonomous isolation of the network defaults to guarantee the business of its sustainable development. The intelligent network will not happen overnight, and H3C will forge ahead with a practical attitude and to guarantee our clients for their digital transformation. Thank you for your attention.